Now, we will start with chapter 8, section 2, thermal energy transfer, right? And a lot of you have already seen most of this, maybe at the lower level, right? The first one we consider is conduction. And we consider conduction, convection, and radiation, right? So, beginning with conduction. Basically, conduction is transfer of heat through a solid. So, let's write that down. Transfer of heat or thermal energy, right? Through a solid. We know that metals conduct heat a lot easier, right? That's why frying pans and cooking utensils are usually made of metal. Rubber, cotton, things that are full of air or have low density normally have lower conductivity, right? That's why we use them as insulators to make it harder for the outside heat to come into your house in the summer and for the heat to escape your house outside in the winter, right? We use the thermal insulators that have low thermal conductivity for that. Next is convection, right? Convection is more related to gases and liquids, and it's by the mixing of gases or liquids at different temperatures, right? And most of you have already seen this in the basic science course, right? You know what conduction and convection are. Conduction is more related to wind, right? As warm air rises, the cool air goes down and it mixes and it transfers heat energy by doing that. Another would be ocean currents. Right? There's hot ocean currents that come from the equator and they move up or down the oceans, particularly the Atlantic Ocean. And as they move, they transfer the heat with them, right, to different places. So these two concepts are not they're not looked into a lot of detail, right? There are equations related to these, but those equations are not studied in the IB at this level, right? One of the equations you might see is, well, the amount of heat transferred depends on first the cross-sectional area, right? Bigger area means a lot more heat can transfer to the solid. It also depends on the thermal conductivity of the object. Right? Higher thermal conductivity like metals will transfer heat faster. It's inversely proportional to the thickness, right? Thicker objects make it a bigger barrier for the heat to pass through. And finally, the amount of heat transferred also depends on the temperature difference. If there's a very big temperature difference, like 1,000 degrees, it will transfer heat a lot faster than if it's 0.1 degrees, right? You're not exactly required to know this equation, but knowing this will help you if you have other types of physics tests. Next is there's a model for this, right? If you have studied chapter 3, you know that temperature is a measurement of kinetic energy, right, of the atoms. Therefore, in conduction, what transfers the energy is the collision from the atoms, right? atomic vibrations. Okay, so next part we study is radiation, right? First, you have seen already what electric heaters do, right? They heat up, they use electrical energy and turn it to thermal energy. But the way they transfer this thermal energy to you mostly is through radiation. It turns red, right? And you can feel the heat coming from the light emitted by it, right? So this is a type of radiation. Hotter objects emit more radiation, colder objects emit less radiation. That's why the higher the temperature of this object is, the more thermal heat it will emit, right? And of course, when it emits thermal heat, it cools down itself. It's losing thermal energy. This thermal energy can be captured by objects around it, right? Something that is in a white container, white being that it reflects a lot of the light, will absorb less of that energy. Something that is black, which means it absorbs more of the light that falls on it, will absorb more of the energy, right? So in this case, if you measure the temperatures of these two containers, you'll get a different temperature. This will be a lower temperature. The black container will be a higher temperature, right? So, and this will be the focus of our discussion today, thermal radiation, okay? So to understand thermal radiation, first, all objects emit thermal radiation. And here we should add the word all. Objects emit, and fill in the blank, thermal radiation. Even things that you don't normally think emits, light. For instance, you, right, as a human being, are at a constant about 37 degrees Celsius, right? And you might not know this, but you emit thermal radiation. You just don't see it because the thermal radiation emitted is low frequency, high wavelength. It's not within our visual spectrum, so we do not see the radiation being emitted by normal objects. Normally, the only time we see thermal radiation is when we heat something above a certain threshold, right? Like fire. Fire is a high temperature. It emits thermal radiation that we are able to see. Metals, when you heat a metal, it turns first red, then orange, then white, right? That is the emission of thermal radiation. The hotter it gets, the shorter the frequency becomes that is emitted, right? So everything emits thermal radiation, first of all. Also in the same way, all objects absorb some of the radiation and reflect the rest. Right? So normally all objects will absorb a certain percentage, right? From 0 to 100, non-inclusive, right? And they will reflect some of the remainder, also from 0 to 100. Normally, if it reflects 100% of all the radiation on it, it looks more white, right? If it absorbs more of the radiation, it looks darker. Sometimes it absorbs some of the wavelengths and not others, and that's how we get colors. If it absorbs all the red light, only the green, blue, and violet lights are left over, right? So you get a mix of those colors. If it absorbs only the red and the violet, then you're left with green, right? Which is what we see in plants. They absorb everything except green, which is reflects. That's why they look green. So all objects absorb some of it and reflect some of it, right? And they do both at the same time, which is the third part. All objects are doing these two at the same time. So they're always absorbing and reflecting some of it, right? But there's one other thing they do is we said they also emit radiation, right? Depending on the temperature. and here is depending on the temperature. Right? So they absorb and they emit, right? And there has to be a balance. They have to reach equilibrium, right?